A single teaspoon of a neutron star would weigh more than Mount Everest. Neutron stars are what remain after a massive star explodes in a supernova. When that star collapses, its core is squeezed so tightly that protons and electrons are crushed together to form neutrons. The result is an object so dense that almost all empty space inside atoms disappears. Even though a neutron star is only about the size of a city, imagine something no wider than a small island. It can contain more mass than our entire sun. That means, if you somehow scooped up just 1 teaspoon of its material, it would weigh around 1 billion tons. That's heavier than all the cars, buildings, and people in your entire country combined. To picture this, imagine compressing Mount Everest into something small enough to fit on a spoon. That's how tightly packed the matter inside a neutron star is. This extreme density shows how powerful gravity can become when a massive star dies. It literally crushes matter into one of the most extreme forms known in the universe. There is a giant cloud of alcohol floating in space, and it's big enough to make trillions upon trillions of drinks. Near the center of our galaxy, astronomers discovered a massive cloud of gas that contains ethyl alcohol, the same type of alcohol found in beverages on Earth. But this is not a small cloud drifting quietly in space. It stretches for hundreds of trillions of miles. That's so wide that if you tried to travel across it in a car at highway speed, it would take far longer than the entire age of human civilization. This cloud exists because space is not completely empty. It contains cold gas and dust, and under the right conditions, simple molecules like alcohol can form naturally. The cloud is extremely cold, far colder than the coldest winter on Earth. So the alcohol is not liquid like in a bottle. It exists as vapor mixed with other gases. Even though the idea sounds funny, this discovery shows something important. Complex organic molecules can form naturally in space. The ingredients for life are not rare. They are drifting between the stars, waiting for the right place to come together. If you fell into a black hole, you wouldn't instantly disappear. You would slowly stretch like spaghetti. This strange effect is called spaghettification. It happens because gravity near a black hole is not equal everywhere. The part of your body closer to the black hole would feel a much stronger pull than the part farther away. That difference in gravity would stretch you longer and longer. Imagine someone pulling hard on your feet while another person pulls your head in the opposite direction. Now imagine that force becoming so strong that your body is stretched thinner than a thread. That's what would happen as you get closer to the center. The stretching happens because black holes are incredibly compact. Some contain more mass than our sun, but are squeezed into a space smaller than a city. That creates gravity so powerful it can trap light itself. The wild part? From far away, someone watching you fall would see you slow down more and more, almost freezing in place. But for you, time would feel normal until the stretching becomes extreme. Black holes don't just swallow things. They twist space and time in ways that break our everyday understanding. There is a planet made partly of diamond. Far out in space, astronomers discovered a planet believed to contain huge amounts of carbon compressed into diamond. The pressure inside this planet is so intense that much of its interior may have turned into solid crystal. Imagine a world where the ground beneath you could sparkle like gemstones in every direction. This happens because the planet likely formed from a star rich in carbon. When the star died, the leftover material clumped together under massive pressure. Over time, that pressure squeezed the carbon so tightly that it may have crystallized, similar to how diamonds form deep inside Earth, but on a much larger scale. To picture this, think about how small a diamond ring is. Now imagine a planet thousands of miles wide, about the size of Earth, but with layers that could be made of diamond. That's like turning an entire world into something harder than any natural material we commonly use. This discovery shows that planets can be wildly different from anything in our solar system. The universe doesn't just repeat the same patterns. It creates worlds that sound almost unreal. Space is not completely silent, but you would never hear the sounds with your own ears. Many people say space is silent, and that's mostly true because sound needs air to travel. In space, there's almost no air, but there are still vibrations moving through hot gas near stars and black holes. Scientists can detect these vibrations using special instruments, and then turn them into sound waves we can hear. One famous example comes from a galaxy cluster, where astronomers found pressure waves moving through superheated gas. These waves are like sound ripples, similar to the ones made when you drop a stone into water. The difference is the scale. The waves there are so massive that one full vibration can take millions of years to complete. To imagine this, think of a single musical note from a piano. Now stretch that note so long that it plays for longer than all of human history combined. That's how deep and slow some of these space vibrations are. When scientists convert these signals into sound, they become eerie, deep tones. It's not noise we could hear naturally, but it proves the universe is not completely quiet. It's just playing on a scale far beyond human senses. As we move forward, feel free to share where you're listening from, or leave a quick thought below. And if this channel means something to you, subscribing is a small way to support the journey. A single bolt of lightning on Jupiter is thousands of times more powerful than lightning on Earth. Storms on Jupiter are not like the ones we see from our windows. They are massive, planet-wide systems that rage for years. Inside these storms, lightning strikes with incredible force. Some of these flashes release so much energy that they outshine entire cities in a single moment. Jupiter is more than 10 times wider than Earth. That means its storms can grow to sizes that would swallow our entire planet. Imagine a hurricane so big that Earth could fit inside it like a marble inside a basketball. Within those enormous clouds, electrical charges build up just like they do in Earth's storms, but on a far greater scale. When the lightning strikes, it can be up to 3 times hotter than a lightning bolt here at home. That's hotter than the surface of the sun. The energy released in one powerful Jovian lightning flash could power millions of homes for days. These giant storms show how extreme weather can become when a planet is made mostly of gas and has no solid ground to slow things down. There is a giant scar on Mars so huge it would stretch across the entire United States. It's called Valles Marineris, and it is the largest canyon system in our solar system. This massive crack in the Martian surface is about 2,500 miles long. That's roughly the same distance from New York to Los Angeles. If you placed it across the United States, it would reach from coast to coast. But length is not the only shocking part. In some places, this canyon is about 4 miles deep. That's much deeper than the Grand Canyon on Earth. Imagine stacking 4 Empire State Buildings on top of each other. The canyon would still be deeper than that. Scientists believe this enormous scar formed billions of years ago, when Mars's crust stretched and cracked as the planet cooled. Later, landslides and erosion made it even wider and deeper. What makes this so fascinating is the scale. Mars is only about half the size of Earth, yet it holds a canyon system far larger than anything here. It shows that even smaller planets can experience dramatic and powerful geological changes. There is a star so large that if you placed it where our Sun is, it would swallow Jupiter. This star is called UY Scuti, and it is one of the biggest stars ever discovered. It is so enormous that its surface would stretch far beyond the orbit of Mars, and possibly even reach Jupiter. To understand how big that is, imagine replacing the Sun with a glowing red ball so large that Mercury, Venus, Earth, and Mars would all be inside it. If Earth somehow orbited this star at the same distance we orbit the Sun, our entire planet would be deep inside the star's outer layers. There would be no sky, just endless hot gas in every direction. Scuti is a red supergiant, which means it is a star near the end of its life. As stars like this run out of fuel, they expand to enormous sizes. Even though it is huge, it is not very dense. In fact, its outer layers are spread out like a thin fog compared to our Sun. Still, its size is hard to imagine. If the Sun were the size of a basketball, Scuti would be taller than Mount Everest. On Venus, a single day is longer than an entire year. Venus takes about 243 Earth days to spin once on its axis, but it only takes about 225 Earth days to go all the way around the Sun. That means if you stood on Venus and waited for the Sun to rise, set, and rise again, you would wait longer than it takes the planet to complete a full trip around the Sun. To picture this, imagine celebrating New Year's Day before you even finish one full day. That's how strange Venus is. Venus also spins backward compared to most planets. On Earth, the Sun rises in the east and sets in the west. On Venus, it would rise in the west and set in the east. The sky would move in the opposite direction. Scientists think this may have happened because Venus was hit by something massive long ago, or because of complex gravitational effects over billions of years. This slow rotation also affects its weather. Venus has a thick atmosphere that traps heat, making it hotter than Mercury, even though Mercury is closer to the Sun. One day on Venus is not just long. It completely changes how the planet behaves. There is a planet where it rains molten glass sideways. This planet is called HD 189733b, and it is a deep blue world that might look beautiful from far away. But it is one of the most violent places ever discovered. Winds there can reach speeds of over 5,000 miles per hour. That's fast enough to circle Earth in less than half a day. Because the planet is extremely hot, tiny particles of glass form in its atmosphere. The powerful winds don't let the glass fall gently like rain on Earth. Instead, the shards blast sideways at incredible speed, like a never-ending sandstorm made of sharp needles. To imagine this, think of standing in a storm where sand is thrown at you faster than a jet airplane flies. Now imagine that sand is actually sharp glass heated to extreme temperatures. There would be no safe place to stand. The planet's blue color likely comes from the way this glass-filled atmosphere scatters light, similar to how Earth's sky appears blue. But unlike Earth, this world is not peaceful. It shows that some planets in the universe are not just different. They are unbelievably extreme. There are zombie stars that refuse to die completely. Normally, when a massive star explodes in a supernova, it destroys itself in one powerful blast. But astronomers have found rare stars that explode and then survive. These are sometimes called zombie stars because they come back after what should have been their final moment. In some cases, the explosion is weaker than usual. Instead of tearing the star apart entirely, it only blows off part of its outer layers. The core remains, damaged but still alive, and it can continue shining for years or even decades afterward. Imagine a firework that explodes in the sky, but instead of disappearing, part of it keeps glowing and burning after the blast. That's similar to what happens with these stars. A typical supernova can briefly outshine an entire galaxy. That's like one light bulb suddenly shining brighter than billions of others combined. The fact that a star can survive such a violent event surprises scientists, because it challenges what we thought we understood about how stars end their lives. These zombie explosions show that even the death of a star can have unexpected twists. There is a cloud in space that contains enough water to fill Earth's oceans trillions of times over. Astronomers discovered a massive cloud of water vapor surrounding a distant quasar, a super bright object powered by a supermassive black hole. This cloud holds more water than all the oceans on Earth combined, multiplied by at least 100 trillion. To picture that, imagine taking every ocean on Earth the Pacific, Atlantic, Indian, Arctic, and Southern, and then copying all that water again and again until you have stacked it up trillions of times. That's how much water exists in this single region of space. What makes this even more surprising is how far away it is. The water is floating billions of light years from us. That means the light we see from it began its journey long before Earth even formed. This water exists as vapor, not liquid, because the environment is extremely energetic and heated by radiation from the quasar. Still, it proves something amazing. One of the key ingredients for life is not rare in the universe. Water is not just an Earth thing. It exists on a truly cosmic scale. If two pieces of metal touch in space, they can permanently stick together. This effect is called cold welding. On Earth, metal surfaces are covered with tiny layers of air, moisture, and dirt. These layers act like a barrier, but in space, there is almost no air at all. If two perfectly clean pieces of metal press against each other, their atoms can bond directly. That means they don't just touch, they fuse. Imagine pressing two pieces of clay together so firmly that they become one solid piece. Now imagine that happening with metal, without heat or glue. That's what can happen in the vacuum of space. This is a serious concern for spacecraft. If moving metal parts accidentally stick together, equipment can fail. Engineers have to design space machines very carefully to prevent this. It happens because atoms want to bond when nothing is in the way. On Earth, the air protects us from this strange behavior. In space, that protection is gone, so in the vacuum of space, metal can behave less like solid objects and more like magnets that permanently lock together. Saturn is so light that it would float in water. That sounds impossible, because Saturn is enormous. It is about 9 times wider than Earth. You could line up more than 760 Earths inside Saturn and still have room left over. It is the second largest planet in our solar system. But here's the surprising part. Saturn is made mostly of gas, mainly hydrogen and helium. Because of that, its overall density is very low. Density is what decides whether something sinks or floats. Wood floats because it is less dense than water. Rocks sink because they are denser. Saturn's average density is actually lower than water. If you could somehow find an ocean big enough, imagine an ocean wider than our entire solar system, Saturn would float on it like a giant beach ball. Of course, such an ocean doesn't exist, but the comparison helps you understand how light Saturn really is for its size. Even though it looks massive and heavy, much of it is made of compressed gas. It's a reminder that size alone does not tell you how heavy something truly is. In space, even giant planets can be surprisingly light. There is a planet where a year lasts less than one Earth day. Some planets orbit their stars so closely that they complete a full trip around their star in just a few hours. One example is a planet called WASP 18b. It circles its star in less than 23 hours. That means its entire year, one full orbit, is shorter than a single day on Earth. To picture this, imagine celebrating New Year's Eve every single day. Before you even finish one full Earth day, that planet has already completed another year. This happens because the planet is extremely close to its star, far closer than Mercury is to our Sun. The intense gravity pulls it into a very tight orbit. Being that close also makes the planet incredibly hot. Its surface temperature is so high that metals could melt there. At that distance, the star would look enormous in the sky, possibly filling a huge portion of it. The planet is also likely locked in place, meaning one side constantly faces the star, while the other side stays in darkness. It shows how different planetary systems can be. Time itself feels completely different, depending on where you are in the universe. The footprints left by astronauts on the moon could last for millions of years. When astronauts from the Apollo missions walked on the moon, They left clear boot prints in the dusty surface. Unlike Earth, the moon has no wind, no rain, and no flowing water to wash things away. There is also no thick atmosphere to cause weather. On Earth, footprints on a beach disappear in minutes when waves come in. Even footprints in dry dirt slowly fade because of wind and small movements in the ground. But on the moon, nothing like that happens. The moon's surface is covered in fine, powdery dust, called regolith. When an astronaut stepped down, the dust stayed in place. Without weather to disturb it, those prints can remain almost unchanged. The only thing that might erase them over time is tiny meteor impacts. Small space rocks constantly hit the moon's surface, but this process is very slow. To understand how long that is, imagine carving your name into dry sand and knowing it could stay there longer than human civilization has existed. The moon preserves history in a way Earth never could. There are planets that are darker than coal. One example is a planet called Tri-ES 2b. It reflects less than 1% of the light that hits it. Fresh asphalt on a road reflects more light than this planet does. If you placed it next to charcoal, the charcoal would actually look brighter. This planet is so dark because its atmosphere likely contains chemicals that absorb almost all incoming light, instead of bouncing light back into space like clouds on Earth do. The planet traps most of it. That makes it appear almost completely black. To picture this, imagine standing in a room with the lights on and placing a basketball in front of you. Now imagine that basketball absorbs nearly all the light. So instead of seeing its surface clearly, it looks like a round hole cut out of reality. Even though it is extremely dark, the planet is also incredibly hot because it orbits very close to its star. The heat may glow faintly red, like the dim glow of hot metal in a forge. It shows that planets are not always bright and colorful. Some worlds in the universe are so dark they almost disappear against the background of space. There is a star that is literally being ripped apart by a black hole right now. When a star drifts too close to a black hole, gravity does not just pull it in gently. The side of the star closer to the black hole feels a much stronger pull than the far side. This difference stretches the star until it tears apart in a violent event called a tidal disruption. Imagine pulling on a ball of soft dough from both ends. If you pull hard enough, it stretches into a long, thin strand before breaking. That is similar to what happens to the star, except the forces involved are beyond anything we experience on Earth. As the star is torn apart, some of its material spirals around the black hole at incredible speed. This creates a bright flare of light that can outshine the entire galaxy for a short time. It is like watching a single spark suddenly glow brighter than billions of stars combined. These events help scientists understand how black holes grow. They do not just sit quietly in space. Sometimes they feed, and when they do, the universe lights up in one of its most dramatic displays. There are rogue planets drifting through space with no star at all. Most planets orbit a star, like Earth orbits the Sun. But some planets have been thrown out of their solar systems. They travel alone through the darkness between stars. These are called rogue planets. Imagine Earth suddenly losing the Sun. The sky would go completely dark. Temperatures would drop far below anything we experience, colder than Antarctica in winter. Within a short time, the oceans would begin to freeze from the top down. Some rogue planets may have been ejected after close gravitational encounters with larger planets. It's like a cosmic slingshot. When massive objects move near each other, their gravity can fling smaller ones away at extreme speeds. To picture the loneliness, imagine a boat drifting in the middle of an endless ocean, with no lighthouse, no shore, and no sunrise, just darkness in every direction. What's surprising is that there may be billions of these wandering planets in our galaxy alone. Some scientists even think a few might still have underground oceans kept warm by internal heat. Not every world belongs to a star. Some travel the universe completely alone. There is a planet that is so hot it glows in the dark all by itself. Some ultra-hot exoplanets are heated to such extreme temperatures that their surfaces glow visibly like red-hot metal in a forge. One example is a rocky planet whose day side can reach around 4,000 degrees Fahrenheit, hot enough to melt most types of rock. To picture that heat, think about a piece of iron placed in a blacksmith's fire. As it heats up, it begins to glow orange and red. Now imagine an entire planet glowing like that. Because it orbits extremely close to its star, the planet is tidally locked. One side always faces the star and becomes incredibly hot, while the other side is cooler but still extremely warm. Even the night side can glow faintly because of the intense heat spreading around the planet. If you looked at it from space, you would not just see reflected starlight. You would see the planet shining with its own fiery glow. It's incredible to imagine a world where darkness does not mean cold, where the ground itself radiates visible light into space. Like a giant ember floating in the void, there is a planet where the sky might glow purple instead of blue. On Earth, our sky looks blue because air molecules scatter blue light from the sun more than other colors. But on some exoplanets, orbiting cooler red stars, the situation could be very different. If a planet's atmosphere contains certain gases and it orbits a red dwarf star, the light coming from that star would be more reddish. When that red light scatters through the atmosphere, the combination of colors could create a sky that appears purple or even deep violet. Imagine stepping outside and seeing a sky tinted like twilight all day long. Not blue, not red, but a rich purple glow stretching across the horizon. The exact color depends on the type of star and the gases in the atmosphere. Small changes in chemistry can dramatically change the way light behaves. To picture how strange that would feel, think about how unusual Earth looks during a sunset when the sky turns pink and orange. Now imagine that being the normal daytime color. It shows that even something as familiar as the color of the sky can be completely different elsewhere in the universe. There is a cloud in space that is so large it could wrap around the Milky Way like a giant fog bank. It's called the Magellanic Stream. This enormous river of gas stretches for more than 600,000 light years. A light year is the distance light travels in 1 year, and even at that incredible speed, it would take 600,000 years to travel from one end of this stream to the other. To picture that size, imagine light racing around Earth 7 times every second, and still needing over 500,000 years to cross it. The Magellanic Stream is made of gas pulled from 2 nearby dwarf galaxies, the Large and Small Magellanic Clouds. As these smaller galaxies orbit the Milky Way, gravity stretches their gas into a long trailing ribbon. This stream contains enough material to help form millions of new stars when it eventually merges more fully with our galaxy. It's incredible to think that galaxies don't just collide. They leave behind enormous rivers of gas stretching across space, slowly feeding larger galaxies over time. There is a star that shines so steadily that scientists use it like a cosmic lighthouse to measure the size of the universe. These stars are called Cepheid variables. Unlike normal pulsating stars that change brightness unpredictably, Cepheids brighten and dim in a very regular pattern. The time it takes them to pulse is directly linked to how bright they truly are. Imagine having a light bulb that brightens and fades in a perfect rhythm, like breathing in and out. If you know how bright it actually is, you can compare it to how bright it appears from far away. The dimmer it looks, the farther away it must be. Some Cepheid stars are tens of thousands of times brighter than our sun. That makes them visible across millions of light years. A light year is the distance light travels in 1 year, and even at that incredible speed, it takes millions of years to cross those distances. To picture this, imagine seeing a lighthouse from across an entire ocean. By measuring how faint it looks, you could estimate how far away it is. These stars helped scientists discover that the universe is expanding. A simple, steady pulse became the key to measuring cosmic distances. There is a planet where it might rain liquid fire from the sky. On certain ultra-hot exoplanets, temperatures are so extreme that rocks melt into lava oceans, but it doesn't stop there. Some of that molten rock can evaporate into the atmosphere, forming clouds made of vaporized stone. Imagine heating a rock in a furnace until it melts and then begins to steam. Now imagine that happening across an entire planet. On the cooler side of the planet, this rock vapor can condense into droplets and fall back down, not as water rain, but as molten rock rain. To picture the heat, think about lava flowing from a volcano. That lava can reach around 2,000 degrees Fahrenheit. On these worlds, entire landscapes may be hotter than that. Strong winds can carry the vaporized rock across the planet at thousands of miles per hour before it falls again. It's incredible to imagine standing under clouds that do not bring water, but glowing drops of liquid stone. In some parts of the universe, even rain can burn like fire. There is a star that is colder than a cup of coffee. Most stars are extremely hot, but a rare type called a brown dwarf can have surface temperatures as low as about 80 degrees Fahrenheit. That's cooler than many summer days on Earth, and close to the warmth of a fresh cup of coffee. To picture this, imagine holding a mug that feels warm in your hands. Now imagine a failed star in space with a surface temperature similar to that. Brown dwarfs form like stars from collapsing clouds of gas, but they do not have enough mass to sustain the powerful nuclear fusion that makes normal stars shine brightly. Because of this, they glow faintly, mostly in infrared light, which human eyes cannot see. Even though they are cooler, they can still be massive, sometimes dozens of times heavier than Jupiter. That means something huge, bigger than any planet, can exist in space at temperatures comfortable enough to feel mild by Earth standards. It's strange to imagine a star that is not blazing hot, but instead quietly glowing at temperatures you might experience on a warm day. There is a place in space where a single day can last longer than the entire history of human civilization. Some planets rotate incredibly slowly. One example is Venus, which takes 243 Earth days to spin once on its axis. Human civilization as we know it has existed for only a few thousand years, yet even that feels short compared to cosmic time. Now imagine a planet that spins even more slowly than Venus. On such a world, the sun would rise and crawl across the sky at an almost unnoticeable pace. Shadows would barely move from one day to the next. To picture it, imagine watching a sunset that takes weeks or even months to finish. The sky would slowly shift colors over an incredibly long time. Slow rotation can happen when a planet is affected by strong gravitational forces from its star. Over time, those forces act like brakes, reducing the planet's spin. It's incredible to think that while we measure our days in 24 hours, some worlds experience daylight that stretches on for months, turning something as simple as a sunrise into a long, drawn-out cosmic event. There is a star that is moving so fast, it will eventually escape the Milky Way forever. Some stars become runaway stars after violent events, such as a nearby supernova explosion. When one star in a pair explodes, the blast can fling its partner away at incredible speed. Imagine two dancers spinning while holding hands. If one suddenly disappears, the other would fly outward from the spin. That's similar to what happens in space. Some of these stars travel at more than 1 million miles per hour. At that speed, you could circle Earth dozens of times in a single hour. Over millions of years, the star will drift farther and farther from our galaxy. Eventually, it will enter the vast emptiness between galaxies, where the night sky would look almost completely dark. To picture the journey, remember that the Milky Way is about 100,000 light years wide. A light year is the distance light travels in 1 year. And even at that incredible speed, it takes 100,000 years to cross our galaxy. It's astonishing that stars, which seem fixed in our sky, can actually be launched into intergalactic exile, traveling alone through deep space forever. There is a planet that may have a layer of diamond thousands of miles thick beneath its surface. Scientists believe that inside Uranus and Neptune, the pressure is so intense that carbon atoms can be squeezed into solid diamond, but on some distant exoplanets that are even richer in carbon, this process could be far more extreme. Imagine taking all the pressure from millions of Earths stacked on top of each other. Deep inside these planets, that crushing force could create a thick shell of diamond surrounding the core. To picture the scale, think about Earth's crust, which is only a few dozen miles thick compared to the whole planet. Now imagine a diamond layer possibly thousands of miles deep, wider than the entire United States from coast to coast. This happens because under extreme pressure and heat, carbon atoms lock into a crystal structure. On Earth, diamonds form deep underground over long periods. In these planets, the same process could occur on a global scale. It's incredible to think that what we consider rare gemstones on Earth might form entire planetary layers elsewhere. In some parts of the universe, worlds may sparkle from the inside out. There is a planet that may have winds hot enough to vaporize metal while racing faster than a bullet. On some ultra-hot exoplanets, surface temperatures can climb above 4,000 degrees Fahrenheit, hot enough to melt iron. But it's not just the heat that's extreme. Winds on these worlds can roar at thousands of miles per hour. Imagine standing in a place where the air itself feels like the inside of a blast furnace. Now imagine that air moving so fast, it could circle Earth in less than a day. These extreme winds happen because one side of the planet constantly faces its star and becomes incredibly hot, while the other side stays much cooler. The huge temperature difference forces air to rush between the two sides at unbelievable speeds. In some cases, vaporized rock and metal can be carried by these winds, creating an atmosphere filled with exotic materials. It's hard to imagine weather that intense. On Earth, even the strongest hurricanes are tiny compared to these planetary windstorms. Some worlds are not just hot or windy. They are full of blazing, metal-scorching gales that never truly calm down. There is a place in space where two entire galaxies are crashing into each other right now. One famous example is the Antennae galaxies. These two massive galaxies are in the middle of a slow-motion collision that will last hundreds of millions of years. Imagine two swirling hurricanes made of billions of stars drifting toward each other. When they meet, their shapes stretch and twist. Long streams of stars are pulled outward like glowing ribbons. Even though galaxies contain billions of stars, the distances between individual stars are so vast that most stars do not directly collide. Instead, gravity reshapes the galaxies, compressing gas clouds and triggering huge waves of new star formation. To picture the scale, remember that a single galaxy can be over 100,000 light-years wide. A light-year is the distance light travels in 1 year, and even at that incredible speed, it would take 100,000 years to cross one galaxy. The collision creates bright blue clusters of young stars, born from gas squeezed by gravity. It's amazing to realize that galaxies are not still and peaceful. They merge, stretch, and reshape each other in enormous cosmic encounters. There is a star that spins so fast, it is shaped more like a flattened pancake than a sphere. One example is the star Achernar. Because it rotates at extremely high speed, the force from its spin pushes its equator outward. Instead of being perfectly round like a ball, it becomes wider around the middle and flatter at the top and bottom. Imagine spinning a ball of pizza dough in the air. As it spins faster, the center bulges outward and the shape stretches. Now imagine that happening to something millions of miles wide. At its equator, Achernar is about 50% wider than it is from top to bottom. That is a huge difference. If Earth were stretched like that, the equator would stick out dramatically compared to the poles. The surface of the equator also moves incredibly fast, hundreds of miles per second. That's faster than most spacecraft ever travel. This flattening happens because rotation creates outward force that fights against gravity. It's incredible to think that some stars are not perfect glowing spheres. They are spinning so rapidly that their very shape is distorted by their own motion. There is a planet where the entire surface may be covered in one single ocean, with no continents at all. Scientists call these ocean worlds. Some of them could have oceans that are not just a few miles deep like Earth's, but possibly 50 to 100 miles deep. Earth's deepest ocean point is about 7 miles down. That means these oceans could be more than 10 times deeper than anything on our planet. Imagine standing on a boat and knowing that beneath you lies water deeper than stacking 10 Mariana Trenches on top of each other. Because the oceans are so deep, the pressure at the bottom would be crushing. It might even form exotic types of ice that exist only under extreme pressure. Ice that forms despite being surrounded by liquid water above. With no continents, weather patterns would be completely different. Massive waves could travel across the planet without ever hitting land. It's incredible to imagine a world where there are no mountains, no beaches, no dry ground at all. Just endless water stretching around the entire globe. There is a cloud in space so large that it contains enough material to create tens of millions of new stars. It's called a giant molecular cloud. These are the coldest and densest clouds in galaxies, made mostly of hydrogen gas mixed with dust. Some of them stretch for hundreds of light years. A light year is the distance light travels in 1 year, and even at that incredible speed, it would take centuries just to cross one of these clouds. To picture the size, imagine traveling at the speed of light, fast enough to circle Earth 7 times in a single second, and still needing hundreds of years to reach the other side. Inside these clouds, gravity slowly pulls gas together into clumps. Over time, those clumps collapse and heat up until nuclear fusion begins. That's how new stars are born. Some giant molecular clouds contain enough gas to form millions of stars the size of our sun. What looks like a faint, misty patch in the sky is actually a vast cosmic factory, quietly building future suns and possibly future solar systems deep within its cold, dark interior. There is a planet where gravity is so strong you would feel like you weigh several times more than you do on Earth. Some super-Earth planets are much heavier than our planet, but only slightly larger in size. Because their mass is packed into a relatively small space, the gravity on their surface becomes extremely powerful. Imagine putting on a backpack filled with heavy weights, then doubling it, then tripling it. On certain dense exoplanets, that's how your body would feel just standing still. On one such world, gravity could be 2 to 3 times stronger than Earth's. If you weigh 150 pounds here, you would feel like you weigh 300 to 450 pounds there. Simply walking would feel like climbing stairs non-stop. Jumping might be nearly impossible. This happens because gravity depends on both mass and size. When a planet has a lot of mass squeezed into a tight space, the pull at the surface becomes intense. It's incredible to think that on some worlds, your own body weight could pin you down. Even simple movements would require tremendous effort under crushing gravity. There is a star system where 3 stars orbit each other in a complex cosmic dance. In some parts of our galaxy, stars do not live alone or in simple pairs. Instead, 3 stars can be locked together by gravity. One example is a triple star system where 2 stars orbit each other closely, while a third star circles farther out. Imagine 2 ice skaters spinning around each other while a third skater circles around both of them. That's similar to how these systems move. In certain triple systems, planets have even been discovered orbiting all 3 stars together. That means if you stood on one of those planets, you might see multiple suns rising and setting in different positions across the sky. The distances involved are huge. The outer star may take hundreds or even thousands of years to complete. One orbit around the inner pair. These systems form when giant clouds of gas collapse and fragment, into multiple stars instead of just one. It's amazing to think that in some corners of the universe, night skies could hold not one sun, not two, but 3 stars locked in a gravitational dance that lasts for billions of years. There is a giant crack on a moon that is longer than the distance across the United States. On Saturn's moon Tethys, there is an enormous canyon called Ithaca Chasma. It stretches for about 1,200 miles. That's roughly the distance from New York to Dallas. Imagine a single crack in the ground running across an entire country. The canyon is also several miles deep. If you stood at the bottom and looked up, the walls would tower above you higher than Mount Everest. Scientists believe this giant fracture formed long ago when Tethys cooled and its interior froze. As water inside turned to ice, it expanded slightly. That expansion may have caused the surface to split open, creating the massive crack. To picture the force involved, think about how water in a bottle can crack the bottle if it freezes. Now imagine that happening on a moon hundreds of miles wide. It's incredible that a small icy moon can hold a canyon so huge it would dwarf anything on Earth. Even distant moons can carry scars that stretch across entire worlds. There is a planet where you could experience sunrise and sunset dozens of times in a single Earth day. Some exoplanets orbit their stars extremely closely, completing one full orbit in just a few hours. Because of this rapid motion, the star would appear to move quickly across the sky. Imagine standing on a world where the sun rises, climbs overhead, and sets again, all before you finish a long lunch. Then it happens again and again. One such planet completes a full orbit in about 8 hours. That means it experiences 3 full years in one Earth day. If the planet rotates in a way that allows day and night cycles, the star would sweep across the sky at incredible speed. To picture how fast that is, imagine celebrating New Year's Eve 3 times before going to bed. These planets are usually extremely close to their stars, often much closer than Mercury is to our Sun. The intense heat makes them harsh and hostile. It's amazing to think that on some worlds time feels completely different. While we measure years slowly, other planets race through them again and again in a single day. There is a star that is so large it would take hours just for light to travel from one side of it to the other. Light moves incredibly fast, fast enough to circle Earth about 7 times in 1 second. Yet in some of the biggest known stars, even light needs hours to cross from one edge to the other. Take a red supergiant star. Some of them are so enormous that if placed where our Sun is, they would stretch beyond the orbit of Jupiter. Jupiter is about 5 times farther from the Sun than Earth is. To picture this, imagine replacing the Sun with a glowing sphere so huge that Mercury, Venus, Earth, Mars, and even Jupiter would all be inside it. That is how massive some of these stars are. Even though these stars are huge, their outer layers are very spread out, almost like a thin fog compared to the dense Sun. That's why they can grow so large. It's hard to imagine something so big that even the fastest thing in the universe, light, needs hours just to cross it. It reminds us that in space, size can reach truly overwhelming extremes. There is a planet where the atmosphere may be made mostly of steam from boiling oceans. On some distant water worlds, scientists believe entire planets could be covered by global oceans hundreds of miles deep. If such a planet orbits too close to its star, the surface water can heat up intensely and begin to evaporate. Imagine turning up the heat under a pot of water. As it boils, steam fills the air above it. Now imagine that happening on a planetary scale. The result could be a thick atmosphere filled with water vapor. This steam blanket would trap heat, making the surface even hotter, like a runaway greenhouse effect. To picture the depth, remember that Earth's deepest ocean point is about 7 miles down. Some of these water worlds may have oceans dozens or even hundreds of miles deep. If you stood on such a planet, if you could, you might see endless ocean below and thick steam-filled skies above. with no land in sight. It's incredible to think that somewhere in the universe, entire planets may exist as vast boiling seas under heavy, cloud-filled atmospheres. There is a star that is literally vibrating like a giant musical instrument. Some stars experience what scientists call starquakes. These are powerful vibrations that ripple through the entire star. The surface rises and falls slightly as waves move through it, almost like the surface of a drum being struck. Imagine hitting a drum and watching the surface shake. Now imagine that drum is larger than our sun. These vibrations can be caused by sudden changes inside the star or by intense magnetic forces. In some cases, especially with highly magnetized neutron stars, the vibrations can be incredibly energetic. To picture the scale, imagine squeezing something heavier than our sun into a sphere only about 12 miles wide, roughly the size of a small city. When such a dense object cracks or shifts slightly, the energy released can be enormous. Astronomers detect these vibrations by studying tiny changes in the star's brightness or radiation. It's like listening to a cosmic symphony, where each vibration tells scientists something about the star's interior. It's amazing to think that stars are not silent, steady objects. Some are constantly ringing with deep, powerful vibrations across space. There is a planet that is so reflective it shines like a giant mirror in space. One example is a world covered in thick, bright clouds made of metallic compounds. These clouds reflect nearly 80% of the light that hits them. For comparison, Earth reflects about 30% of sunlight. Fresh snow reflects around 80 to 90%. That means this planet can be almost as reflective as a field of brand new snow, but across an entire world. To picture it, imagine taking a giant white marble and placing it in space. When light from its star hits it, most of that light bounces straight back. This extreme brightness happens because of its dense cloud cover. The clouds are made of tiny droplets or particles that scatter light very efficiently. Instead of absorbing heat, the atmosphere sends much of the light back into space. If you looked at this planet from far away, it would appear unusually bright compared to darker worlds nearby. It's fascinating that in the darkness of space, some planets don't hide in shadow. Instead, they gleam brilliantly, shining like cosmic mirrors, reflecting the light of their stars. There is a star that is being slowly shredded into a long stream of gas, like taffy being pulled apart. When a star wanders too close to a black hole, gravity does not just swallow it whole instantly. The side of the star closer to the black hole feels a much stronger pull than the far side. This difference stretches the star into a long, thin shape before it finally breaks apart. Imagine pulling a piece of warm caramel candy from both ends. It stretches into a long string before snapping. That's similar to what happens to the star. As the star is torn apart, part of its material spirals around the black hole in a glowing disk. The rest is flung outward into space. The event can release a burst of light so bright it briefly outshines all the stars in its galaxy. To understand the scale, picture squeezing something heavier than our sun into a space about the size of a city. That's the kind of gravity doing the pulling. These events show that black holes are not just silent traps. Sometimes when they feed, they put on a violent display, stretching entire stars into glowing ribbons across space. There is a black hole that burped so powerfully it left a dent in a galaxy cluster larger than the Milky Way. At the center of some galaxy clusters, supermassive black holes occasionally release enormous blasts of energy. In one case, astronomers discovered a gigantic cavity carved into the hot gas surrounding the cluster. This cavity is so large that the entire Milky Way galaxy could fit inside it. Imagine dropping a stone into a calm lake and watching the splash create a hollow space in the water. Now imagine that hollow space being large enough to contain billions of stars. The explosion did not come from the black hole itself, but from material falling into it. As gas spirals inward, Some of the energy is redirected outward in powerful jets. These jets push surrounding gas aside, inflating enormous bubbles in space. To picture the scale, remember that light travels around Earth 7 times in 1 second. Even at that speed, it would take tens of thousands of years to cross one of these cavities. It's incredible to think that something invisible can release enough energy to reshape regions of space bigger than entire galaxies. There is a planet that may have clouds made of pure sapphire and ruby dust. On some extremely hot exoplanets, temperatures and pressures allow aluminum oxide, the same material that forms sapphires and rubies on Earth, to exist as tiny particles high in the atmosphere. To picture this, think about how gemstones form deep underground on Earth, under heat and pressure. Now imagine those same materials floating in the sky as microscopic grains. Scientists have detected signs of aluminum oxide in the atmospheres of certain distant worlds. When the atmosphere cools slightly at higher altitudes, this material can condense into fine dust, forming glittering mineral clouds. Imagine looking up and seeing clouds that, if collected and compressed, could become gemstones. These planets are often heated to thousands of degrees Fahrenheit, hot enough to vaporize rock. Powerful winds can then carry these materials around the globe. It shows something amazing about the universe. Materials we consider rare and valuable on Earth may exist naturally in vast amounts elsewhere. In some skies, the clouds themselves may be made from the same substance as precious jewels. There is a place in space where a star orbits a black hole every few hours, moving at a large fraction of the speed of light. In some systems, a normal star is locked in a tight orbit around a black hole. Because the black hole is incredibly compact and massive, the star has to move extremely fast to avoid falling in. Imagine tying a ball to a string and spinning it in a tight circle. The shorter the string, the faster you must spin it to keep it from dropping. Now imagine that string is gravity, and the ball is a star as massive as our Sun. In certain systems, the star completes an orbit in just a few hours. To do that, it must travel millions of miles per hour, a noticeable fraction of light speed. Light can circle Earth about 7 times in 1 second. Even moving at a small fraction of that speed is extraordinary. At those speeds, strange effects happen. Time for the star slows slightly compared to distant observers because of both its speed and the black hole's gravity. It's incredible to think that somewhere in the universe, entire stars are racing around invisible objects faster than anything we've ever built. There is a moon that may hide an ocean deeper than all of Earth's oceans combined. Jupiter's moon Europa is covered in a thick shell of ice. Beneath that frozen crust, scientists believe there is a global ocean of liquid water. This ocean may be 60 miles deep. The deepest part of Earth's oceans is about 7 miles. That means Europa's ocean could be nearly 9 times deeper. To picture that depth, imagine stacking 9 Mariana Trenches on top of each other. That's the kind of scale we're talking about. Europa stays warm inside because of Jupiter's gravity. As Europa orbits, Jupiter squeezes it slightly, creating internal heat, similar to bending a paperclip back and forth until it gets warm. The surface shows cracks and lines where the ice has shifted, hinting at movement below. Some scientists think plumes of water may even shoot into space from hidden cracks. It's incredible to think that far from the sun, under miles of solid ice, there may be a vast, dark ocean. More water could exist there than in all of Earth's seas combined, hidden beneath a frozen shell in deep space. There is a type of explosion so bright that it can briefly outshine the entire galaxy it lives in. It's called a superluminous supernova. When certain massive stars reach the end of their lives, they don't just explode, they detonate with extraordinary power. For a short time, the explosion can shine brighter than hundreds of billions of stars combined. Imagine every star in the Milky Way turning on at once. Now imagine one single explosion glowing even brighter than that. Some of these events are powered by a rapidly spinning neutron star left behind after the explosion. As it spins, it pumps extra energy into the expanding cloud of debris, making it shine even more intensely. To picture the brightness, think about how the sun dominates our sky during the day. Now, multiply that brilliance billions of times. These explosions can be seen from billions of light years away. That means the light we detect today began its journey when Earth itself was still forming. It's astonishing that one dying star can briefly overpower the combined light of an entire galaxy, turning darkness into something unbelievably bright for a short moment. There is a star so powerful that it can blow away entire planetary systems. Some massive stars produce intense stellar winds, streams of charged particles blasting outward at millions of miles per hour. These winds are so strong that they can strip away gas and dust from nearby young planets before those planets fully form. Imagine turning on the strongest leaf blower you can find and pointing it at a pile of sand. The sand would scatter in every direction. Now imagine that on a scale large enough to clear out material around entire planets. One famous example is Eta Carinae, a massive star more than 100 times heavier than our Sun. It shines millions of times brighter and throws off huge amounts of material into space. These stellar winds can shape the surrounding region, carving bubbles and pushing gas outward for light years. A light year is the distance light travels in 1 year, and even at that incredible speed, it would take years to cross these blown-out cavities. It's incredible to think that a single star can act like a cosmic storm machine, clearing out space around it and deciding which nearby planets get to survive. There is a place in space where it snows sideways. On some exoplanets that are tidally locked, one side constantly faces the star while the other remains in endless night. The temperature difference between the two sides can be extreme. This creates powerful winds that roar across the planet at thousands of miles per hour. On certain worlds, scientists believe minerals like silicates can condense into tiny solid particles high in the atmosphere. When these particles fall, they don't drift gently downward, like snow on Earth. The violent winds blast them sideways across the sky. Imagine standing in a blizzard, where snow is not falling from above, but shooting across the horizon like a sandstorm. Now imagine that snow made of tiny rock particles instead of frozen water. These winds can move faster than most jet airplanes. At that speed, even small particles become dangerous. This happens because the planet's constant day side heats the atmosphere intensely, while the night side stays much cooler. Air rushes between them non-stop. It shows that weather in the universe can be far more extreme than anything we experience on Earth. Even snow can fall in ways that feel completely alien. There is a star that is slowly being eaten by a hidden companion you can't see. In some star systems, a normal star orbits an invisible black hole. The black hole's gravity pulls gas from the star, forming a swirling disk of superheated material around it. As the gas spirals inward, it heats up so much that it glows brighter than many ordinary stars. Imagine a whirlpool in water. If you drop leaves near it, they slowly spiral toward the center. Now imagine that whirlpool made of gravity, and the leaves are streams of hot gas torn from a star. The black hole itself cannot be seen, because not even light can escape it. But the glowing disk around it can shine intensely, sometimes flashing in X-rays. In some systems, this feeding process can cause sudden outbursts of brightness. It's like a quiet campfire that suddenly flares up when more fuel is added. To picture the force involved, imagine something with the mass of several suns compressed into a space about the size of a city. That intense gravity pulls material from its companion relentlessly. It's strange to think that some stars are slowly losing pieces of themselves to something completely invisible. There is a place in space where gravity is so strong that it bends light like a magnifying glass. This effect is called gravitational lensing. When a massive object, like a galaxy or a cluster of galaxies, sits between us and a more distant object. Its gravity bends the light coming from behind it. Imagine placing a clear glass marble over a piece of paper with words on it. The marble bends the light and makes the letters look stretched or curved. In space, gravity does the same thing, but on a cosmic scale. Some galaxy clusters are so massive that they create giant arcs of light around them. These arcs are actually distant galaxies whose light has been warped and stretched as it passes through the cluster's gravity. To picture the scale, imagine a cluster containing thousands of galaxies, each with billions of stars. The combined mass bends space itself. This bending allows astronomers to see objects that would otherwise be too faint or too far away. It's like nature built a giant telescope in space. Gravity does not just pull objects, it reshapes the path of light, turning the universe into its own optical illusion. There is a planet where one side may be covered in endless lava oceans. On some ultra-hot exoplanets, temperatures are so extreme that rock melts across the surface. One example is a world so close to its star that a full year lasts less than a single Earth day. Because it is tidally locked, one side always faces the star and never cools down. Imagine standing on the day side. Instead of solid ground, you would see glowing orange lava stretching to the horizon, like an entire planet turned into a volcanic sea. The temperature can reach over 4,000 degrees Fahrenheit. That's hot enough to melt most types of rock. To picture that heat, think about lava flowing from a volcano on Earth. Now imagine that lava not just flowing in rivers, but forming oceans thousands of miles wide. The night side of the planet is cooler, but strong winds may carry vaporized rock from the hot side to the dark side, where it condenses and falls like rocky rain. It's incredible to think that in some parts of the universe, oceans do exist, but they are made of molten stone instead of water. There is a planet so dense that a single teaspoon of its material would weigh more than a mountain. Some exoplanets, like certain super-Earths, are made almost entirely of iron and rock packed tightly together. One example is a planet that is much heavier than Earth but not much larger. That means all its mass is squeezed into a small space, making it incredibly dense. To picture density, think about the difference between a pillow and a solid metal ball of the same size. The metal ball feels much heavier because its material is tightly packed. Now imagine an entire planet that is packed far more tightly than Earth. If you could somehow scoop up a teaspoon of material from such a world, which is impossible in reality, it would weigh as much as a large mountain on Earth. The gravity on its surface would be crushing. You would feel many times heavier just standing there. This happens because intense pressure during the planet's formation forced heavy elements like iron into a compact structure. It shows that planets are not all built the same way. Some are light and gassy like Saturn, others are compact and heavy, with matter packed together, almost beyond imagination. There is a star that explodes not once, but repeatedly. Most stars that explode in a supernova are destroyed forever, but there is a rare type called a recurrent nova. In these systems, a dense white dwarf star pulls gas from a nearby companion star. The gas builds up on its surface over time. Imagine slowly piling dry leaves into a heap. At first, nothing happens, but if enough heat builds up underneath, the pile suddenly ignites. After it burns out, you can start piling leaves again. That's similar to what happens here. As the white dwarf steals gas, pressure and temperature rise on its surface. Eventually, the gas ignites in a powerful thermonuclear blast. The explosion makes the star suddenly brighten dramatically. But unlike a supernova, the star survives. After the blast, the process begins again. Some of these systems explode every few decades. To picture the brightness, imagine a faint star suddenly shining thousands of times brighter in the night sky. It's incredible to think that in some parts of the universe, stars don't just die once, they erupt, over and over, like cosmic fireworks that refuse to stop. There is a planet that orbits two suns at once. One example is Kepler 1.6b. Instead of circling a single star like Earth does, this planet moves around two stars that orbit each other. In its sky, there would be two suns rising and setting. Imagine standing on a world where you see two glowing stars moving across the sky. Sometimes they would be close together. Other times they would be far apart. Shadows on the ground would split into two. Kepler 1.6b orbits both stars together, completing one full trip in about 229 Earth days. The stars themselves circle each other much more quickly. Their combined gravity keeps the planet in motion around them. To picture the motion, imagine two dancers spinning around each other, while a third dancer circles both of them from a distance. That's similar to how this system works. The planet itself is about the size of Saturn. Even though it may not be suitable for life, it proves something amazing. Solar systems do not always have just one sun. In parts of the universe, sunsets can happen twice, or overlap, creating skies very different from anything we see on Earth. There is a galaxy that is shaped like a giant ring floating in space. It's called Hoag's object. Instead of looking like a spiral, like the Milky Way, or an oval like many other galaxies, it has a bright, circular ring of stars surrounding a nearly empty center. It looks almost like a glowing donut in the darkness of space. To picture this, imagine a cosmic life preserver floating in the ocean of the universe. The outer ring is packed with hot, young blue stars, while the middle is mostly clear. The ring stretches about 120,000 light years across. A light year is the distance light travels in 1 year. And even at that incredible speed, it would take 120,000 years to travel from one side of the ring to the other. That makes it slightly larger than our entire Milky Way galaxy. Scientists are still debating how it formed. One idea is that a smaller galaxy passed through the center long ago, triggering waves of star formation that created the ring. It's incredible that gravity can arrange billions of stars into such a clean, circular structure. In a universe full of spirals and blobs, one galaxy decided to look like a perfect ring. There is a planet where the ground may be covered in burning ice. On Pluto, temperatures are so cold, around minus 375 degrees Fahrenheit, that water behaves like rock. Ice there is as hard as concrete. But Pluto also has frozen nitrogen and methane on its surface. When sunlight hits certain regions, the frozen nitrogen can slowly turn directly into gas, almost like dry ice on Earth. This process can create faint haze layers in Pluto's thin atmosphere. To picture how cold that is, imagine the coldest place you've ever experienced. Now drop the temperature by more than 200 degrees. At those levels, even gases freeze solid. Scientists have observed large plains on Pluto, made of nitrogen ice. Some of these plains show patterns that suggest the ice slowly flows, like thick lava, but made from frozen gas instead of molten rock. Imagine a landscape where mountains are made of water ice as hard as stone, and glaciers are made of frozen nitrogen. Pluto shows that ice does not always mean slippery and fragile. In the outer solar system, ice can act like solid rock, shaping mountains and valleys in ways that feel completely alien to Earth. There is a black hole that is spinning so fast it twists space around it like a whirlpool. Some supermassive black holes rotate at nearly the maximum speed allowed by physics. As they spin, they drag space itself along with them. This effect is called frame dragging. Imagine stirring a thick soup in a pot. As the spoon spins, the soup near it begins to swirl. Now imagine space itself behaving like that soup, twisting and spiraling because of a spinning black hole. These black holes can spin at close to the speed of light. At their edges, the faster they spin, the more energy they can release. In some cases, they launch enormous jets of glowing particles that stretch for thousands of light years. long enough that even light would need thousands of years to travel from one end to the other. To picture that distance, imagine light racing around Earth 7 times every second, and still needing thousands of years to cross those jets. This spinning motion does not just affect nearby gas, it changes how time and space behave around the black hole. It's incredible to think that something invisible can twist the fabric of the universe itself just by spinning. There is a planet where glass clouds may drift across the sky. On some extremely hot exoplanets, temperatures are so high that materials we think of as solid, like rock and sand, can melt and even turn into vapor. When that vapor cools at higher altitudes, it can form clouds made of tiny particles of silicate, the same material found in glass on Earth. Imagine looking up and seeing clouds that are not made of water droplets, but microscopic shards of glass floating in the air. On certain worlds, these clouds may glow slightly because of the intense heat below. Winds thousands of miles per hour can push these glass particles across the planet. To picture the heat, think about how sand melts into glass in a furnace. Now imagine an entire planet acting like that furnace, hot enough to vaporize rock during the day. When temperatures drop slightly at higher levels in the atmosphere, the vapor condenses into fine particles, forming glass clouds instead of rain clouds. It shows how alien weather can be. On Earth, we expect clouds to bring water. On some distant worlds, clouds may be made from materials sharp enough to cut. There is a planet where the sunset could last for years. On some distant worlds that orbit very slowly or are tidally locked in unusual ways, the transition from day to night can happen incredibly slowly. One example is a planet that takes hundreds of Earth days to rotate just once. That means the sun would move across the sky at a slow crawl. Imagine watching the sun set on Earth. It takes about 10 to 20 minutes to dip below the horizon. Now imagine that same sunset stretching not for minutes, not for hours, but for months. If you stood near the edge between the day side and night side, a region called the Terminator, you might live in a constant twilight. The sun would hover near the horizon for an extremely long time, barely moving. On such a world, shadows would stretch endlessly across the landscape. The sky could glow in deep oranges and reds for what feels like forever. This happens because rotation controls how fast a planet experiences day and night. Slow rotation means slow sunrises and slow sunsets. It shows that even something as familiar as a sunset can behave completely differently elsewhere in the universe. There is a planet that is slowly being torn apart by its own star. One example is a planet called Kepler 1520b. It orbits so close to its star that the intense heat is literally melting its surface. The temperature is high enough to turn rock into vapor. That vapor then escapes into space, forming a long, dusty tail behind the planet. Imagine holding an ice cube too close to a fire. Instead of melting into water, it would turn straight into steam. Now imagine that happening to an entire planet made of rock. The planet is small, about the size of Mercury, and its gravity is not strong enough to hold on to all that vaporized material. Over time, it loses more and more mass. Its dusty tail can stretch for millions of miles, long enough to wrap around Earth dozens of times. From far away, it looks almost like a comet, but it is actually a disintegrating world. Scientists believe that eventually, this planet may completely vanish. It's strange to imagine a planet not just orbiting its star, but slowly evaporating because it ventured too close, being erased piece by piece by intense heat. There is a place in space where lightning flashes may be thousands of times more powerful than on Earth. On Saturn, giant storms can create lightning bolts so bright they can be seen from space. Some of these flashes release energy strong enough to power entire cities for days. The storms themselves can grow so large they wrap around the entire planet. Imagine a thunderstorm so massive that Earth could fit inside the swirling clouds. That is the scale of some storms on Saturn. These lightning storms happen because warm gases rise from deep within the planet and mix with colder layers above. The movement builds up electrical charges, just like in Earth's storms, but on a much larger scale. Saturn is mostly made of hydrogen and helium, and it has no solid surface to slow storms down. Without mountains or land to weaken them, these systems can last for months. To picture the brightness, imagine a lightning bolt lighting up the sky over your city. Now imagine that flash being visible from millions of miles away in space. Even in the outer solar system, far from the sun, nature still creates powerful and violent weather. There is a planet that is literally being stretched into the shape of a tear. Some planets orbit so close to their stars that gravity pulls them out of shape. One example is WASP 121b. The star's gravity stretches this planet so strongly that it is no longer round. It is pulled into an oval, almost like a water droplet about to fall. Imagine holding a soft rubber ball and squeezing one side harder than the other. The ball would stretch and bulge. Now imagine that happening to an entire planet thousands of miles wide. WASP 121b is so close to its star that a full year there lasts only about 30 Earth hours. The intense gravitational pull not only stretches the planet, but also heats it to extreme temperatures. Parts of its atmosphere are even escaping into space. To picture the force involved, think of the moon's gravity pulling on Earth's oceans to create tides. Now, multiply that effect enormously. Instead of moving water a few feet, the gravity reshapes the entire planet. It shows that in space, gravity does more than hold things together. Under extreme conditions, it can slowly pull a world apart and reshape it entirely. There is a river of stars flowing through our galaxy right now. It's called a stellar stream. These streams form when a small galaxy or star cluster gets pulled apart by the Milky Way's gravity. Instead of disappearing instantly, its stars stretch out into long, thin trails that wrap around our galaxy. Imagine pulling apart a loaf of soft bread. Instead of breaking cleanly, it stretches into strands. That's similar to what gravity does to these smaller systems. Some stellar streams stretch for tens of thousands of light years. A light year is the distance light travels in 1 year, and light moves fast enough to circle Earth about 7 times in a single second. Even at that speed, it would take tens of thousands of years to cross one of these streams. These rivers of stars slowly orbit the galaxy, tracing paths left behind by ancient cosmic collisions. They are like fossil evidence, showing us how the Milky Way grew by absorbing smaller systems over billions of years. When you look up at the night sky, you are not just seeing stars sitting still. Some of them are part of vast flowing streams, drifting silently through space like glowing rivers in the dark. There is a cloud of gas in space that is so large it could swallow our entire solar system many times over, and it is heading toward the Milky Way. It's called the Smith Cloud. This massive cloud of hydrogen gas stretches about 11,000 light years long and 2,500 light years wide. A light year is the distance light travels in 1 year, and even at that incredible speed, it would take thousands of years just to cross this cloud. To picture its size, imagine our entire solar system as a tiny coin. The Smith Cloud would be like a continent compared to that coin. This cloud is moving at hundreds of miles per second and is on a path that will eventually collide with the Milky Way's disk in about 30 million years. That might sound far away, but in cosmic time, it's relatively soon. When it merges with our galaxy, it could trigger the birth of millions of new stars as its gas mixes with the Milky Way's material. It's incredible to think that giant rivers of gas drift between galaxies, sometimes crashing into them and helping create new generations of stars. There is a planet where the winds blow faster than the speed of sound. On Neptune, the most distant giant planet in our solar system, Winds can reach over 1,200 miles per hour. That is faster than a commercial jet, and close to the speed of sound at sea level on Earth. To picture that speed, imagine a hurricane so powerful that it could carry you from one major city to another in under an hour, without even using an airplane. These are the kinds of winds Neptune experiences. What makes this even more surprising is that Neptune receives far less sunlight than Earth. It is about 30 times farther from the sun than we are. You would expect it to be calm and frozen. Instead, it is one of the most violent weather worlds we know. Scientists think the planet generates heat from its interior, which powers these massive storms. Giant dark storm systems have been observed swirling through its deep blue atmosphere. Even at the edge of our solar system, far from the sun's warmth, nature can still create extreme, roaring winds that move faster than sound itself. There is a place in space where diamonds the size of mountains may exist. When some massive stars die, their cores collapse into neutron stars. In rare cases, one of these neutron stars can cool and crystallize over time. Scientists believe that parts of its interior may turn into a giant solid crystal, essentially a cosmic diamond. To understand how extreme this is, imagine taking the mass of our Sun, which is more than 300,000 times heavier than Earth, and squeezing it into a sphere only about 12 miles wide, roughly the size of a small city. The pressure inside becomes so intense that atoms are crushed tightly together. Under those crushing conditions, carbon can form a crystalline structure. One famous example is a white dwarf, nicknamed Lucy, which is thought to contain a crystallized carbon core. Picture a diamond so large, it would dwarf Mount Everest. Except this diamond would weigh more than our Sun. It shows how different matter can behave under extreme pressure. Materials we think of as precious gemstones on Earth can exist on an unimaginable scale in space. In the universe, even something as familiar as a diamond can become something truly colossal. There is a type of star that blinks on and off like a cosmic heartbeat. These are called pulsating variable stars. Instead of shining steadily like our Sun, they physically expand and shrink over and over again. When the star expands, it cools slightly and becomes dimmer. When it shrinks, it heats up and becomes brighter. This cycle can repeat in hours, days, or weeks. Imagine a giant glowing balloon in space, slowly breathing in and out. As it swells, its light fades a bit. As it tightens, it shines brighter. Some of these stars are enormous, many times wider than our Sun, yet they can grow and shrink by millions of miles during each pulse. That's like a star changing size by more than the distance between Earth and the Moon every cycle. This happens because of a balance between gravity pulling inward and pressure pushing outward. When the balance tips slightly, the star begins to rhythmically pulse. These heartbeats are incredibly useful for astronomers. Certain types pulse at very predictable rates, allowing scientists to measure distances across space. So some stars are not steady lights in the sky. They are breathing, pulsing beacons across the universe. There is a wall in space so enormous that it contains hundreds of thousands of galaxies. It's called the Sloan Great Wall. This structure stretches for about 1.4 billion light-years. A light-year is the distance light travels in 1 year, and even at that incredible speed, it would take 1.4 billion years just to cross from one end to the other. To picture that size, imagine shrinking the entire Milky Way galaxy down to the size of a grain of sand. Even then, this wall would stretch across a continent. The Sloan Great Wall is not a solid object like a brick wall. It is a vast chain of galaxy clusters, linked together by gravity. Galaxies form along these massive filaments, creating a long, connected structure across space. When astronomers first discovered it, they were surprised because it challenged ideas about how evenly matter should be spread across the universe. On the largest scale, the universe looks like a giant web. The Sloan Great Wall is one of the thickest threads in that web. It's hard to imagine something so large that even light, the fastest thing in existence, needs over 1 billion years to cross it. There is a star that is literally being blown away by its own light. Some extremely massive stars produce such intense radiation that the light pushing outward almost balances the star's own gravity pulling inward. In rare cases, the radiation becomes so powerful that it begins to strip material off the star's surface. Imagine holding a pile of sand in your hand while a strong wind blows across it. Grain by grain, the sand gets carried away. Now imagine that happening to a star that is dozens of times heavier than our Sun. These stars can lose mass at an incredible rate, sometimes shedding an amount equal to Earth's mass in just a few years. The ejected material forms glowing clouds around the star. This happens because light carries momentum. When huge amounts of light energy stream outward, they push against the gas on the star's surface. If the push is strong enough, gravity cannot fully hold the outer layers in place. Over time, this steady loss can change the star's future, affecting how it eventually explodes. It's strange to think that something as gentle as light can become powerful enough to tear apart a star. There is a star that passes through our solar neighborhood every so often, and it can disturb comets like shaking a snow globe. One example is Scholz's star. About 70,000 years ago, it passed through the outer edge of our solar system, not near Earth, but through the distant Oort cloud, a vast shell of icy objects that surrounds our system. To picture how far that is, imagine the planets as tiny beads around a campfire. The Oort cloud would stretch thousands of times farther out, forming a huge bubble around everything. Scholz's star passed through that outer bubble. Even though it did not come close to the Sun itself, its gravity may have nudged some icy objects. Those objects could slowly drift inward over millions of years and become comets. Imagine gently shaking a giant snow globe. The snowflakes don't fall immediately. They drift slowly over time. That's similar to how a passing star can send comets toward the inner solar system. Stars are not fixed in place. They move through the galaxy like ships on a dark ocean. And sometimes, one of them sails close enough to gently disturb our cosmic backyard. There is a mountain on Mars that is nearly 3 times taller than Mount Everest. It's called Olympus Mons, and it is the largest volcano in our solar system. It rises about 13 miles high. Mount Everest is about 5.5 miles tall, so Olympus Mons is more than twice its height. If you stood at its base, the peak would be so high that you wouldn't see it clearly, because Mars curves away beneath it. To picture how wide it is, Olympus Mons stretches about 370 miles across. That's roughly the distance from New York City to Washington, D.C. and back again. Imagine a volcano so large it could cover an entire state. Mars has weaker gravity than Earth, which allowed lava to pile up higher and higher over time. Also, Mars does not have moving tectonic plates like Earth. On Earth, plates shift and move volcanoes away from their lava sources. On Mars, the lava kept erupting in the same place for millions of years. The result is a volcano so massive it makes anything on Earth look small. It shows that even a smaller planet can create landscapes on a truly gigantic scale. There is a cloud of gas in space that smells like rotten eggs and tastes like raspberries. Near the center of our Milky Way, scientists have detected chemicals such as hydrogen sulfide and ethyl formate inside giant clouds of gas and dust. Hydrogen sulfide is the same gas that gives rotten eggs their terrible smell. Ethyl formate is a chemical that gives raspberries part of their flavor. Of course, no one is floating there with their nose or tongue. Scientists identify these chemicals by studying the light they absorb and emit. Each molecule leaves a unique fingerprint in the light spectrum, allowing researchers to know exactly what is present. To picture this, imagine a cloud in space, larger than our entire solar system. Now imagine that, if you could somehow stand inside it safely, it would carry the scent of rotten eggs, mixed with fruity sweetness. This shows something fascinating. Space is not just empty darkness. It contains complex organic molecules, the same kinds of building blocks that are connected to flavors and smells on Earth. Even in the cold vacuum between stars, chemistry is happening. The ingredients for life are drifting silently through space, waiting for the right conditions to come together. There is a region in space where galaxies are arranged like foam in a giant cosmic sponge. When astronomers map the universe on its largest scale, they see something surprising. Galaxies are not spread out evenly. Instead, they form long filaments and walls that surround enormous empty regions called voids. Together, this pattern looks like a three-dimensional web or foam. To picture it, imagine soap bubbles clustered together in a sink. The thin soap walls form a network, and inside each bubble is mostly empty space. The universe is similar. The walls are made of galaxies and dark matter, while the bubbles are vast voids with very few galaxies. Some of these voids are hundreds of millions of light years across. A light year is the distance light travels in 1 year, and even at that incredible speed, it would take millions of years just to cross one of these empty regions. What's mind-blowing is that this structure formed from tiny differences in matter shortly after the universe began. Small variations grew over billions of years into this enormous cosmic web. On the largest scale, the universe doesn't look random. It looks like an immense, organized sponge. Stretching across space, there is a planet where it rains iron. On a planet called WASP 6b, temperatures are so extreme that iron can melt and turn into vapor in the atmosphere. On the side facing its star, the heat is intense enough to vaporize metal. Strong winds then carry this iron vapor to the cooler night side of the planet. When the iron vapor reaches the cooler side, it condenses and falls as liquid iron rain. To picture this, imagine looking up at the sky during a storm. Instead of water droplets falling, glowing metal droplets would be raining down. It's like a blacksmith's workshop happening across an entire planet. WASP 76b is so close to its star that a full year there lasts less than 2 Earth days. The planet is also tidally locked, meaning one side is always facing the star while the other side remains in darkness. This creates extreme temperature differences between the two sides. The winds on this planet can reach thousands of miles per hour, helping move the vaporized metal around. It shows that in some parts of the universe, weather is not just different. It is made of materials we normally think of as solid metal. There is a moon with lakes and rivers, but they are not made of water. Saturn's moon Titan has liquid lakes, rivers, and even rain. But instead of water, these lakes are made of methane and ethane, which are types of natural gas on Earth. Because Titan is extremely cold, about -290 degrees Fahrenheit, these gases behave like liquids. To understand how cold that is, Antarctica's coldest temperature was around -128 degrees Fahrenheit. Titan is more than twice as cold as that. If you stood on Titan, you might see dark, smooth lakes stretching across the landscape. You could watch rain fall from thick orange clouds, but the water would not be safe to touch. It would be liquid fuel. Titan is larger than the planet Mercury and has a thick atmosphere, something rare for a moon. Its surface even has waves on its methane seas, similar to small waves on Earth's oceans. It's incredible to think that weather systems, clouds, rain, rivers, can exist in such a different chemical form. Titan shows that Earth-like features do not always require Earth-like materials. In the universe, even lakes can be made of something entirely unexpected. There is a star that is so bright, if it replaced our sun, it would make daytime on Earth brighter than welding sparks. One example is a blue hypergiant star. Some of these stars shine millions of times brighter than our sun. That means if you swapped our sun with one of them, the light hitting Earth would be so intense it could damage your eyes instantly. To picture this, imagine the brightness of the sun right now. It already makes you squint. Now multiply that brightness millions of times. The sky would not just be blue, it could appear almost white from the overwhelming light. These stars are incredibly massive, sometimes more than 100 times the mass of the Sun. Because they are so massive, they burn through their fuel extremely fast. While our Sun will live for about 10 billion years, a blue hypergiant might only live a few million years. Like a giant bonfire that burns bright, but quickly. Their surface temperatures can reach over 50,000 degrees Fahrenheit, far hotter than the Sun's surface. They show that in space, brightness often comes with a cost. The most powerful stars live the shortest lives. There is a galaxy that is slowly eating another galaxy right now. Our own Milky Way is pulling in a smaller galaxy called the Sagittarius Dwarf Galaxy. Over billions of years, gravity has been stretching and tearing it apart. Its stars are being stripped away and added to the Milky Way. Imagine two whirlpools in water. If a small whirlpool drifts too close to a larger one, it gets pulled in and broken apart. That's what's happening on a galactic scale. The Sagittarius Dwarf Galaxy wraps around the Milky Way in long streams of stars. These streams stretch across the sky like faint rivers of light. Over time, the smaller galaxy will completely disappear as a separate object. This process is normal in the universe. Large galaxies grow by absorbing smaller ones. It's how they gain more stars and mass. To understand the scale, remember that a galaxy contains hundreds of billions of stars. Yet gravity can still reshape and merge entire systems over time. Galaxies may look peaceful in the night sky, but they are constantly moving, colliding, and consuming one another in slow, silent cosmic dances. There is a giant bubble in space, so large that our entire solar system would fit inside it millions of times. This bubble is called the local bubble. It is a huge region of space surrounding our solar system where the gas is much thinner than normal. It stretches for about 1,000 light years across. A light year is the distance light travels in 1 year, and light moves fast enough to circle Earth about 7 times in a single second. To picture 1,000 light years, imagine traveling at the speed of light. Even then, it would take 1,000 years just to cross this bubble from one side to the other. Scientists believe this bubble formed from several supernova explosions millions of years ago. When massive stars exploded, they blasted away surrounding gas, creating this enormous cavity. Our solar system happens to sit inside this giant, low-density region right now. It's like living inside a vast cosmic bubble, carved out by ancient stellar explosions. Even though space already feels empty, this region is even emptier than most. We are traveling through a giant hollow area shaped by long-dead stars. There is a planet that is shaped more like an egg than a sphere. Most planets are round because gravity pulls everything evenly toward the center, but some planets spin so fast that they bulge at the middle and flatten at the top and bottom. One example is a planet called WASP-12b. This planet is stretched by both its rapid spin and the strong gravity of its nearby star. Instead of being perfectly round like a basketball, it looks more like a slightly squashed football. To picture this, imagine spinning a water balloon very fast. As it spins, the middle pushes outward, while the top and bottom flatten. Now imagine that happening to an entire planet, thousands of miles wide. 12b is so close to its star that gravity is literally pulling it out of shape. The star's gravity stretches the planet, making it longer on one side. Over time, this stretching may even cause the planet to lose material into space. It shows that not all planets are neat, perfect spheres. Some are warped and distorted by the powerful forces around them, shaped by gravity like soft clay being gently pulled apart. There is a place in space where time actually moves slower. This happens near very massive objects, like black holes. The stronger the gravity, the more it bends space and time. Near a black hole, gravity becomes so intense that time itself slows down compared to places farther away. Imagine you have two clocks. One stays on Earth, the other is placed near a black hole. If someone could survive near the black hole and later return, they would find that less time passed for them than for the person on Earth. This isn't science fiction. It has been measured on a smaller scale. Even on Earth, time moves slightly slower at sea level than on top of a mountain because gravity is stronger closer to Earth's center. The difference is tiny, only fractions of a second, but it's real. Now imagine that effect multiplied enormously near a black hole. A few hours near it could equal years far away. To picture it, think of time as a flowing river. Near a black hole, the river slows to a crawl. Gravity doesn't just pull on objects, it stretches and bends time itself. There is a planet that is slowly evaporating into space. One example is a small rocky world orbiting extremely close to its star. The heat is so intense that parts of the planet's surface are melting and turning into vapor. This vapor then escapes into space, forming a long tail behind the planet, similar to a comet's tail. Imagine placing a sugar cube next to a powerful blowtorch. Slowly, the sugar would melt and turn into smoke. Now imagine that happening to an entire planet. The planet is so close to its star that a full year there lasts less than one Earth day. The constant heat weakens its gravity's hold on surface material. Over time, more and more of the planet is stripped away. Its dusty tail can stretch for millions of miles. That's long enough to wrap around Earth dozens of times. Scientists believe that over millions of years, the planet could shrink dramatically, or even disappear completely. It's strange to imagine a world not just orbiting its star, but slowly dissolving because it is too close. Some planets are not stable forever. They are gradually being erased by their own suns. There is a star that is moving so fast it is escaping our galaxy. These are called hypervelocity stars. One of them is racing away from the Milky Way at more than 1.5 million miles per hour. At that speed, you could travel from New York to Los Angeles in about 7 seconds. That is fast enough to completely break free from the gravity of our entire galaxy. Scientists believe this happens when a star gets too close to the supermassive black hole at the center of the Milky Way. If two stars orbit each other and pass near the black hole, one star can be captured while the other is slingshotted outward at extreme speed, like a rock launched from a cosmic slingshot. Imagine swinging a ball tied to a string and suddenly letting go. The ball flies outward rapidly. Now imagine that on a galactic scale. Over millions of years, this star will travel into intergalactic space, leaving behind billions of other stars. It will drift alone between galaxies. It's incredible to think that stars, which seem fixed and permanent in the sky, can actually be flung across the universe at unimaginable speeds. There is a moon with a volcano that erupts non-stop, and it throws lava hundreds of miles into space. Jupiter's moon Io is the most volcanically active place in our entire solar system. It has over 400 active volcanoes. Some of its eruptions shoot lava fountains up to 300 miles high. Mount Everest is only about 5.5 miles tall. That means Io's lava can blast more than 50 times higher than the tallest mountain on Earth. Imagine a volcano so powerful that its eruption would send molten rock far beyond Earth's atmosphere. This happens because Io is constantly squeezed by Jupiter's powerful gravity. As Io orbits, Jupiter pulls on it unevenly, stretching and compressing the moon over and over. That motion creates intense internal heat, like bending a metal paperclip back and forth until it gets hot. The surface of Io is covered in colorful sulfur deposits from its constant eruptions. Instead of oceans or forests, the landscape looks like a pizza covered in melted cheese and bright red sauce. Io shows that some worlds are not calm and stable. Some are shaped every day by non-stop, explosive power. There is a star that is older than the Milky Way galaxy itself. One example is a star known as HD 140-283. often called the Methuselah star. It is estimated to be about 13 billion years old. The universe itself is about 13.8 billion years old, which means this star formed very soon after the universe began. To understand how old that is, imagine compressing the entire history of the universe into one calendar year. Humans would only appear in the last few seconds before midnight on December 31st. This star would have formed in the first month of that cosmic year. What makes this fascinating is that the Milky Way galaxy was still forming when this star was born. It likely came from an early generation of stars and later became part of our galaxy through ancient mergers. This star contains very little heavy material like iron. That tells scientists it formed before many heavy elements existed. Early stars were made mostly of hydrogen and helium, the simplest elements. It's incredible to think that when this star first began shining, there were no planets like Earth, no galaxies fully shaped, just a young universe beginning to organize itself. There is a planet where the sky would glow red even at night. This happens on some tidally locked planets that always show the same side to their star. One side is in constant daylight, and the other side is in endless night. But on certain worlds orbiting small red stars, the night side may never become completely dark. That's because red dwarf stars are cooler and redder than our sun. Their light can scatter through thick atmospheres in strange ways. Powerful winds may carry glowing gases from the hot day side to the cooler night side. The result? A faint red glow in the sky, even when the star itself is not visible. Imagine living somewhere where sunset never fully turns into darkness. Instead of a black sky filled with stars, the horizon glows dim red, like the color of a campfire, fading but never going out. These planets often orbit extremely close to their stars, sometimes so close that a year lasts only a few days. Being that close locks one side in permanent daylight. It shows how different night can be in the universe. Darkness, as we know it on Earth, may not exist everywhere. There is a black hole that weighs as much as 66 billion suns. It sits at the center of a distant galaxy and is one of the most massive black holes ever measured. To understand how extreme that is, imagine taking our sun and copying it 66 billion times. That is the amount of mass packed into a region not much larger than our solar system. If this black hole replaced the sun, its event horizon, the point where nothing can escape, would stretch far beyond the orbit of Pluto. Everything inside that distance would be swallowed. Black holes grow by pulling in gas, dust, and even entire stars. Over billions of years, some of them become unbelievably massive. Even though they are called black, the area around them can glow brighter than whole galaxies as matter spirals inward and heats up. To picture the scale, imagine shrinking Earth down to the size of a pea. Now imagine placing something that weighs more than all the stars in our galaxy combined into a space not much bigger than a city compared to that scale. That's how extreme it is. Some black holes are not just big, they are cosmic giants beyond everyday imagination. There is a type of explosion in space so powerful that it releases more energy in a few seconds than the sun will produce in its entire lifetime. It's called a gamma-ray burst. These bursts happen when massive stars collapse or when two neutron stars crash into each other. For a brief moment, they become the brightest events in the universe. To understand how extreme that is, imagine the sun shining steadily for about 10 billion years. Now imagine taking all that energy and releasing it in just a few seconds. That's the scale of a strong gamma-ray burst. The beam of energy shoots out like a focused flashlight, but instead of visible light, it sends out intense gamma radiation. If one of these beams were pointed directly at Earth from close enough, it could damage our atmosphere. Thankfully, most gamma-ray bursts happen very far away. When astronomers detect one, it often comes from billions of light years across space. That means the light we see today left before Earth even formed. These bursts show how violent the universe can be. In just seconds, they can outshine entire galaxies and briefly become the most powerful light sources in existence. There is a cloud in space so large that it contains enough material to build millions of suns. One example is the Orion molecular cloud. This enormous cloud of gas and dust is a stellar nursery where new stars are being born right now. It stretches for hundreds of light years. A light year is the distance light travels in 1 year, and light moves fast enough to circle Earth about 7 times in a single second. To picture its size, imagine traveling at the speed of light. Even then, it would take centuries just to cross this cloud from one side to the other. Inside this cloud, gravity slowly pulls gas and dust together into clumps. Over time, those clumps grow denser and hotter until they ignite and become new stars. The cloud contains enough raw material to form hundreds of thousands, possibly millions, of stars the size of our sun. Think of it like a giant cosmic factory, except instead of producing cars or buildings, it produces entire solar systems. What looks like a faint, cloudy patch in the night sky is actually a massive region of creation, quietly building future stars and planets on a scale almost impossible to imagine. There is a star that spins so fast, it almost tears itself apart. This type of star is called a millisecond pulsar. Some of them spin hundreds of times every single second. That means in the time it takes you to blink once, the star could spin hundreds of times. To picture this, imagine taking something as massive as our sun and shrinking it down to about 12 miles wide, roughly the size of a small city. Now imagine that tiny, ultra-dense object spinning faster than a kitchen blender on its highest setting. That's what's happening. The surface speed at its equator can reach millions of miles per hour. If it spun just a little faster, the force could overcome gravity and start ripping material off the star. These stars spin so quickly because they often steal material from a nearby companion star. As that material falls in, it transfers energy and speeds up the rotation, like pushing a merry-go-round over and over. Each time the star spins, it sends out beams of radiation like a lighthouse. From Earth, we detect these beams as steady pulses. It's incredible to think that something so small can spin so fast without flying apart. There is a storm on Jupiter that has been raging for more than 300 years. It's called the Great Red Spot. This storm is so large that Earth could fit inside it. Imagine looking up at the sky and seeing a hurricane big enough to swallow our entire planet whole. That is the scale we are talking about. The Great Red Spot is a giant swirling storm in Jupiter's atmosphere. On Earth, hurricanes lose strength when they pass over land because land slows them down. But Jupiter is made mostly of gas. There is no solid ground to weaken the storm, so it keeps spinning. The winds inside this storm can reach over 400 miles per hour. That's faster than most tornadoes on Earth. At that speed, you could drive from one major city to another in less than an hour. Scientists have been observing this storm since the 1600s. That means it has lasted longer than some countries have existed. Even though it has been slowly shrinking in recent years, it is still massive and powerful. It shows that weather in our solar system can be far more extreme and long-lasting than anything we experience here on Earth. There is a magnet in space so powerful it could erase every credit card on Earth from halfway to the moon. These objects are called magnetars. They are a rare type of neutron star with the strongest magnetic fields ever discovered. A magnetar's magnetic field can be trillions of times stronger than Earth's. To understand how extreme that is, imagine Earth's magnetic field as a small fridge magnet. A magnetar would be like a magnet so strong it could tear atoms apart from thousands of miles away. If a magnetar came within about 100,000 miles of Earth, less than half the distance to the moon, its magnetic field could disrupt electronic devices and wipe magnetic data instantly. That's how intense it is. Magnetars form when massive stars collapse after exploding in a supernova. The collapsing core spins rapidly and concentrates its magnetic field into a tiny space about the size of a city. Imagine squeezing the mass of our sun into something only about 12 miles wide, roughly the size of a small town. That compression creates unbelievable magnetic power. They can also release sudden bursts of energy that briefly outshine the sun by huge amounts. Magnetars are not just dense, they are some of the most extreme objects in the universe. There is a region in space where a single cloud could block the light of millions of stars. It's called a dark nebula. These are thick clouds of gas and dust that are so dense they prevent light from passing through. Even though stars may be shining behind them, we can't see that light because the dust absorbs and scatters it. To picture this, imagine shining a flashlight through clear air. The light travels easily. Now imagine trying to shine that same flashlight through a thick wall of smoke. The beam would fade and disappear. A dark nebula works the same way, but on a massive scale. Some dark nebulae stretch for dozens of light years. A light year is the distance light travels in 1 year, and light moves fast enough to circle Earth about 7 times in a single second. Yet even that speed takes years to cross these clouds. Inside these dark regions, new stars are often being born. The same dust that blocks light also gathers under gravity and slowly collapses into new suns. So what looks like a blank, dark patch in the sky is actually a hidden nursery, quietly creating future stars behind a curtain of cosmic dust. There is a planet so hot that it rains molten rock. One example is Kepler 10b, a rocky planet that orbits extremely close to its star. Its surface temperature can reach over 3,000 degrees Fahrenheit. That's hotter than most lava flowing from volcanoes on Earth. To picture that heat, imagine putting a rock into a furnace until it glows bright orange. Now imagine an entire planet covered in glowing liquid rock oceans. Because the planet is so close to its star, one side constantly faces the star while the other side remains in darkness. The day side becomes hot enough to melt rock into vapor. Strong winds may carry this rock vapor to the cooler night side, where it condenses and falls as molten rock rain. Think of rain on Earth, water droplets falling from clouds. Now replace those droplets with liquid stone falling from the sky. This happens because the planet is locked in place by gravity, always showing the same face to its star. The extreme temperature difference between its day and night sides creates violent conditions. It shows that some rocky planets are not solid and stable like Earth. Some are more like glowing oceans of fire under a constant blazing sun. There is a place in space that is colder than anywhere naturally found on Earth. It's called the Boomerang Nebula. It is the coldest known natural object in the universe. Its temperature drops to about minus 458 degrees Fahrenheit. That's just 1 degree above absolute zero, the coldest temperature physically possible. To understand how cold that is, the coldest temperature ever recorded in Antarctica was about minus 128 degrees Fahrenheit. The Boomerang Nebula is more than 3 times colder than that. At those temperatures, almost all molecular motion nearly stops. This extreme cold happens because the nebula is expanding very rapidly. When gas expands quickly, it cools down, similar to how air coming out of a spray can feel cold. But on a cosmic scale, this effect becomes dramatic. The nebula formed from a dying star that is ejecting its outer layers into space at high speed. As the gas rushes outward, it cools to incredibly low temperatures. It's strange to imagine something in space being colder than the empty background of the universe itself. Yet this expanding cloud of gas has managed to create one of the coldest natural environments ever discovered. The largest known structure in the universe is so huge that light takes billions of years just to cross it. It's called a cosmic supercluster complex, a massive web of galaxies linked together by gravity. One of these structures stretches for about 10 billion light years. A light year is the distance light travels in 1 year. Light moves so fast, it can circle Earth about 7 times in a single second. Yet even at that speed, it would take billions of years to travel from one end of this structure to the other. To picture this, imagine turning the entire Milky Way galaxy into a tiny grain of sand. Now imagine lining up billions of those grains across the sky. That still wouldn't match the scale. What makes this mind-blowing is that the universe was once thought to be fairly even and smooth on large scales. Discoveries like this challenge that idea. Matter in the universe forms enormous filaments and clusters, like a giant cosmic spiderweb stretching across space. We are not just inside a galaxy, we are inside a cluster of galaxies, which is inside something far larger, a structure so vast that even light struggles to cross it. There is a diamond rain happening inside Uranus and Neptune. Deep inside these icy giant planets, the pressure is so extreme that carbon atoms may be squeezed into solid diamonds. Scientists believe that lightning storms high in the atmosphere break apart methane gas, which contains carbon. The carbon then sinks deeper into the planet, where the pressure is crushing. To understand that pressure, imagine stacking thousands of Earths on top of you. The weight would be overwhelming. Inside Uranus and Neptune, the pressure is millions of times stronger than what we feel at sea level. Under those conditions, carbon atoms are forced tightly together and can form diamonds. These diamonds may then fall downward like rain toward the planet's core. Picture standing in a storm where instead of water droplets, tiny diamonds are falling from the sky. Except this storm is happening thousands of miles below thick clouds, hidden from view. Scientists have even recreated small versions of this process in laboratories, using powerful lasers to mimic the extreme pressure. It means that somewhere in our solar system, there may be oceans of liquid diamond and showers of sparkling crystals deep beneath the clouds. There is a moon in our solar system, with geysers that shoot water into space taller than Mount Everest. Saturn's moon Enceladus has cracks near its south pole that spray jets of water vapor and ice particles high above its surface. Some of these plumes rise hundreds of miles into space. Mount Everest is about 5.5 miles tall, so these geysers are dozens of times taller than the tallest mountain on Earth. Imagine standing near a fountain that shoots water so high it disappears beyond the sky. That's similar to what's happening on this tiny moon. What makes this even more fascinating is where the water comes from. Beneath Enceladus's icy crust lies a global ocean of liquid water. The moon is constantly squeezed by Saturn's gravity, creating heat inside. That heat keeps the ocean from freezing solid. Some of the water escapes through cracks and forms the massive plumes. Spacecraft have even flown through them and detected chemicals that could support life. This means there is a salty ocean hidden under thick ice, far from the sun, yet still active. It shows that life-friendly environments might exist in places we once thought were completely frozen and lifeless. The sun loses about 1 million tons of mass every single second. That sounds impossible, but it's true. The sun produces energy through nuclear fusion. Deep inside its core, hydrogen atoms are smashed together to form helium. In this process, a tiny amount of mass is converted directly into energy. Even though the amount lost each second is about 1 million tons, the sun is so enormous that this loss barely affects it. To understand how big 1 million tons is, imagine stacking about 150,000 fully loaded school buses together. That's roughly how much mass the sun turns into energy every second, and it has been doing this for about 4.6 billion years. This mass doesn't just disappear, it becomes sunlight, the energy that warms Earth, powers plants, drives weather, and makes life possible. Every ray of sunlight hitting your skin was once a tiny bit of the sun's mass. Even at that huge rate of loss, the sun has enough fuel to keep shining for about another 5 billion years. It shows how powerful fusion is, turning matter itself into pure energy on a scale we can barely imagine. If you could drive a car straight up at highway speed, it would take you more than an hour just to reach space. Space does not begin right above our heads. The commonly accepted edge of space, called the Kármán line, is about 62 miles above Earth's surface. That might not sound far compared to distances between cities, but straight up is very different from driving forward. If you drove upward at 60 miles per hour, about normal highway speed, it would take you a little over 1 hour to reach space. And that is only the beginning. Satellites orbit much higher than that. To picture 62 miles, imagine stacking more than 1,000 Mount Everest mountains on top of each other. That's roughly how high space begins compared to sea level. This shows something interesting. Earth's atmosphere is like a very thin blanket wrapped around a giant planet. Compared to Earth's size, that 62-mile layer is thinner than the skin on an apple. We live at the very bottom of a shallow ocean of air. Above us, space is closer than most people imagine, yet still far beyond what we can reach without powerful rockets.